This is Radio TV Phono Nut, and I wasn't going to do another record player video so soon, but since somebody smarted off in one of the comments about they was tired of seeing all the record player videos, I thought I'd post another one. And if somebody doesn't want to see it, then guess what? They don't have to watch it. But anyway, this is going to cover something that I got a request for a while back. Someone asked me to do a more in-depth video as far as the preamp circuit that I use for these little one-tube wonders and what needs to be done. I did that a while back in a video, but I probably wasn't as thorough as I should have been. So I'll try to be a little bit more thorough today, and maybe you can get something out of this. What we have here is a little RCA Victor 3-speed one-tube wonder record player from 1954. It uses a single 25L6 output tube. Some of them use 25 C5s, some of them use a 25 EH5. Some actually use two tubes, a rectifier tube and some sort of output tube. But pretty much the circuitry is all basically the same. This originally had one of the flat metal 3-volt crystal cartridges with your little thumb screw sticking out the front that holds the needle in. And of course that 3-volt crystal cartridge had long since expired. Well, the only thing semi-modern that will come close is an 89T static like what they use in the school record players, and that's what I installed in here. And if you really don't want to go to the trouble of adding a preamp stage, that's probably the cartridge you should go with, because it'll give you the most output since it puts out 1.3 volts. But on some records it still won't give you very much volume. It'll be better volume than putting like a Crosley cartridge, which is somewhere around 0.3 volts, or a Fan Steel P228, which is something like 0.8 volts. And that's turned wide open, and as you can hear, it's okay, but really shouldn't have to turn it wide open to get decent results. Here's a copy of the schematic for the original circuit, and yes, I will post a scan to this somewhere in the video so you can draw this out if you want to, or get a better look at it. Nothing fancy, just motor in series with a tube filament. Power supply, which was a selenium rectifier, it's now silicon. And coming off our first filter cap, we go up through our output transformer to the plate of our output tube. Go through this resistor, which is 4.7K. Coming off of our second filter, we go up to our screen grid. And on our cathode, we have a 150 ohm resistor to ground. Also from the cathode, a 0.082 microfarad capacitor going from the cathode to chassis. And then we have this isolation resistor, 220K ohm between chassis ground and circuit ground. Now normally there's like a 0.047 capacitor in that application. And this capacitor here is usually not present in a lot of designs. I don't know why it's that way in this set, but whatever. Then we have our pickup cartridge, one side to chassis, going through a 0.001 capacitor, which is also not present in a lot of models. Other end of the cap goes to the volume control. Other end of the volume control connects to chassis. And in some cases that's connected to actual circuit ground, but companies like to be different, whatever works. Then center of the volume control connects to this 27K resistor, and the other side of the resistor connects to the control grid of the output tube. Now, we're going to do an FET based preamp circuit for this, but before we do that, we need to prepare this amplifier circuit for that additional stage, and this is what we need to do in order to do that. We have to make a few minor changes to this circuit. The first thing we need to do is connect a 0.01 600 volt capacitor in parallel with our audio output transformer primary winding. if that capacitor is not already present in your model. Now in some cases there will be a tone control connected across here with a capacitor in series with a tone control, and if that's already there, then you can probably get by without adding the 0.01 capacitor across here. So we'll go ahead and add that capacitor now. Okay, there's our capacitor added to the circuit. And like I said, I will post a scan of this probably at the end of the video, and you can tell that what I've drawn in with an ink pen is our additions to the factory schematic. Now the second thing we need to do, if it's not already present in your set, and many sets have this one didn't, is we want to add a cathode bypass electrolytic capacitor from our cathode of the output tube to ground. The value needs to be 22, 33, 47, 68 microfarad. It's not really critical, and 25 volts is a good working voltage. I think in this one, we used a 68 microfarad. I've already added one because it give it a tad bit more gain with the cartridge that's in there. Okay, there we go. I just noted 22 microfarad to 68 microfarad, 25 volts. Make sure your plus terminal of the capacitor is connected to the cathode, and our negative terminal of the capacitor, which will be the banded end of the capacitor, will connect to circuit ground. Now the next thing we need to do is look at our cathode bias resistor for the output tube. In most cases it's 150 ohm, and that's what it needs to be, or at least 150 ohm. But I've seen them where the cathode resistor would be 100 ohm, 82 ohm, even 68 ohm. If it's anything less than 150 ohm, you need to up the value to 150 ohm 1 watt resistor, because the cathode is where we're going to be getting our voltage for our preamp circuit, and if the cathode resistor is too low, there's not going to be enough voltage on our cathode to drive the preamp circuit. So there's our notation, 150 ohm 1 watt resistor. Now finally, what we need to do is break this connection, and we can just probably go ahead and remove this 27K resistor from the circuit. I tried jumping it out in my set as it is, and it didn't make one bit of difference in operation. I really honestly don't even know why it's there. Some companies use it, some don't. Alright, once you break that connection, we need to place a 470K ohm half watt resistor between the control grid and circuit ground. Okay, now that we have this resistor removed from circuit, we now have our 470K resistor from control grid pin 5 to circuit ground. And our preamp stage will connect between the output of the volume control, which is actually the center pin of the volume control, and our control grid. Here's our FET preamp diagram, and this paper is well ragged, so I'm going to redraw this and try to make it a little cleaner for everybody to read, and I'll scan that where you can see it in the video and copy it down if you'd like. Okay, here's our diagram for the FET preamp circuit, and I'll now go over everything here. Okay, here we are. I'll go over this. This is our volume control. It's on the existing amplifier chassis. Bottom end goes to ground. Top end goes to our plus terminal of the cartridge. The cartridge will be grounded just like it was in the original circuit. Center pin of the volume control connects to one side of a 0.01 capacitor, and then the other side of the capacitor connects to a 1 megohm resistor, with the other side of the resistor connected to circuit ground. And also from the capacitor resistor junction, we go to our gate of the MPF 102 FET, and then we go to our source terminal. Positive end of a 10 microfarad 25 volt electrolytic capacitor connects to our source terminal, negative end to ground. Also to our source terminal, one end of a 4.7 k ohm pot that's wired as a rheostat, and then you can see the bottom end of our pot comes up and connects to our center wiper, and then that connects to circuit ground. Our drain terminal comes over here to a 4.7 k ohm resistor. It comes down here to our test point, which I'll explain in a minute. And then at the 4.7 k ohm resistor, we have a 47 microfarad 25 volt cap tied to that, with the ground side of the cap going to circuit ground. And at this junction between the 4.7 k resistor and the 47 microfarad capacitor, we have a 100 ohm resistor, and that connects to our output tube cathode. That's where it gets its voltage to operate the preamp circuit. And also connected to the drain here, we have our 0.01 microfarad capacitor, and the other end of it connects to our output tube control grid. Now here's our bottom view of the transistor, drain, source, gate. Don't get those terminals mixed up. Now, a little something about this test point here. After warm up, measure the B plus at the test point. So positive end of your digital multimeter here, negative end of your digital multimeter on circuit ground, and take a recording and record what that voltage says. And then once you make a reading of that voltage, move your positive voltmeter lead up here to the drain terminal, and then adjust this 4.7 k ohm pot to measure about half of what you measured here at this TP voltage here. And then that will get your voltages lined up correctly with what they ought to be, and then at that point the preamplifier should work. Okay, I'm getting carried away here, and I'm not giving credit where credit is due. This schematic is not something that I came up with on my own. This is something that was provided to the members of the Facebook record player group by Chris Cuff. I know many of you know who he is. He's very popular in the field of vintage electronics, and especially record player repair and restoration. But anyway, he and another one of the members of that group put their heads together and came up with this. So thank you for providing this for us, and I just like to give credit where credit's due. Alright, now that we have that out of the way, let's get the record player apart, get it torn open, and make the necessary modifications and make this thing more of a pleasure to listen to. Okay, here's our amp chassis. Now take note there is a alternate tube preamp circuit that you can use on this, and if you want to interested in that, you can pretty much look through the Sam's Photo Facts and just find one of the 3-tube RC or 2 or 3-tube RCA Victor 45 players with a 6AV6 tube in it, and that'll give you a suitable circuit for that. But in this case, we really don't have any room on the chassis to put such a thing, with the output transformer right there in the way, and under here in this area we've got a bunch of components, so in cases such as this, it's better just to use the FET circuit that is really simpler to build and takes up less space. Here we are opened up. The first thing we need to do is remove this resistor that goes from the center of the volume control to pin 5 of the 25L6 output tube, and then we'll connect our 470 k ohm resistor from pin 5 to circuit ground. And like I said before, given how I have these components placed, there's really not a lot of room to put another tube socket. Yes, I could tear the whole chassis down and start over, but that's just a lot of unnecessary time consumption. Okay, we have our amplifier prepared. That capacitor there is the one across the audio output transformer, And then this resistor here, that blue thing, is the 470k ohm from the control grid, pin 5 to ground. We already have our 150 ohm cathode resistor and cathode bypass capacitor in place, so that's taken care of. So now we need to figure out how we're going to construct our circuit and where we're going to mount it, because there's really not enough room on the amplifier chassis to do it without it looking sloppy. We could build the FET preamp circuit on a piece of phenolic board. The problem of mounting it would be an issue, and I don't want it flipping and flopping in the wind. Or we could build it on a long terminal strip and mount the terminal strip somewhere here on the motor board. We just need to make sure and mount it in a location where when we drill a hole in the motor board, we can bolt it in place without the bolts being seen. So in other words, the turntable platter is going to have to cover up the mounting bolts. I have one big terminal strip left. How lucky am I? Now we need to mount this on the motor board, because the motor board is obviously wooden or masonite or something that's not conductive, whatever it's made of, because I'm going to need every terminal on here to construct this thing. Okay, everything's coming right along. I had to add a extra bit of wire to the one of the leads on our transistor because it wasn't long enough. Now this is our 4.7k ohm pot. This is what I ordered looks like. It's a little small pot that was made for PC board mounting, but I can still add some extra component leads off of old bad components to this and make the leads long enough to reach over. But you can order any kind of 4.7k ohm pot that you can get your hands on. You know, in this case, a 4.7k ohm pot's a 4.7k ohm pot. Okay, here's our leads attached to the pot, and we'll need to trim them down to size, run some shrink tubing over them so they don't short out to anything, and then mount it to our terminal strip. The one that's bridged together goes to ground, and the other one goes to the FET, the S pin, source pin, which is the center pin. Okay, it's all put together. Ground, signal input, red is B+, blue is signal output. Now, tried to make it as neat as I could, but you know, these modern components that have short leads that are not designed for point-to-point terminal strip mounting, they're designed for PC board mounting. Sometimes had to extend the leads a little bit. All my wiring appears to be correct, so unless I got some bogus FETs or unless I cremated something with the heat from my soldering iron, this should work. And speaking of bogus parts, you have to be really careful about that these days, because a lot of what you get is not what they say it is. It's some bogus crap from China that if it works at all, it'll work poorly. I remember years ago I ordered some TV parts, horizontal output transistors and regulator ICs that were priced so cheap that it seemed to be too good to be true, which turned out to be the case. Well, all the horizontal output transistors shorted as soon as power hit them, and the regulator transistors or ICs or whatever they were dead as a doornail. So sometimes the cheapest price is not always the best deal. Okay, we have everything installed. I'm on my test point junction, reading 7.65 volts, so we need to move our voltmeter to the drain pin and set the little potentiometer to about half that value. Well, you might know I'd get everything in here like it needs to be, and the darn thing won't work right. Got it turned wide open, and I'm actually getting less bump than I was getting before. When I play a record on it, it's Distortion City. When I try to set the bias like it's supposed to be, that ain't right. So tomorrow I'm coming back out here. I'm not doing nothing else to this tonight, because I have learned in the past that when you get flustered and get pissed off, the best thing to do is walk away from it, because you will end up doing something that will result in the item being EOL'd and will never work again. So I got to come back out here tomorrow or whenever I want to and see what's going on. I don't know whether we wired something up wrong, I call myself checking everything, or whether we indeed got a dud part. Because those FETs did come from eBay. And they could have been some rejects from China for all I know. And I checked over all my wiring and it seems to be just fine. I can't find any connections that are broken loose. All my component values seem to be correct. So I'm going to come down here tomorrow and we're going to look at this FET, because we could have very well gotten a bad one. Of course, I ordered 10 of them, but it would probably be too much to ask for one of the 10 in that bag to actually be good. Okay, it looks like we indeed got some bogus FETs from our eBay vendor. I tried another FET on the original terminal strip design. Exact same results, about 7.5 volts at the TP point. And then on our drain pin, it varied between 6.9 and 6.5 volts, depending on the setting of our trim pot. And that's totally wrong. I should be able to get half of whatever as I measured at TP on our drain terminal based on the adjustment of the pot here. So I had a sudden memory burst and remembered that I had this little module here that I had built for some other record player, and for whatever reason I didn't use it. So I wired it temporarily in place, and guess what? It works just fine. Now I know with the YouTube audio processing it's a little hard to tell the difference here, but trust me, I don't have to turn this up wide open now to get decent results. In fact, when I turn it up all the way now, it distorts, so in actuality this thing could probably stand a little bit better speaker, but we'll leave the original one alone. Now this just backs up what I said earlier in the video about junk parts, and based on some of my experiences from my TV repair days, I should have known better. All the parts on this little module came from Mouser Electronics, which is a reputable electronics supplier. A lot of these discount parts houses, whether they be on or off of eBay, buy stuff from China that consists of floor sweepings, counterfeit parts, parts that are known DOA defective, and parts that may work but may not perform as well as the originals. So, you know, if the price seems to be too cheap, too good to be true, it probably is. And in the case with what I got off of eBay, that's $10.47 for 10 transistors. It's just, I might as well have just flushed it down the toilet. But when I decide to get some more MPF 102s, I'll make sure to order them from Mouser Electronics. And I'll tell you another little story from my TV repair days. Not long before the flat screen craze took off, someone gave me a nice 36-inch RCA home theater floor model TV, and the flyback transformer was bad. And at that time I already knew about the hit or miss quality of generic parts, so there was a place called Tritronics. I think they're known as Encompass or Encompass or something like that. Incompetent should be more like it. But they were supposed to be an RCA distributor, parts dealer, and I called them up and I told them I want an exact RCA replacement part for this flyback. I don't want some generic something. I want the exact replacement part. Well, she assured me that's what I'd get. Well, the part came in and it was some no-name generic something in a black plastic housing that was actually physically a little bit smaller than the original RCA part. Well, after fiddling with the pins for what seemed like 2 hours to get them to line up on the circuit board, I installed it onto the chassis, turned the set on, it worked good. I watched it for about 10 minutes, turned the set off because it was getting to be time to call it a day, Come back down the next day and was going to turn it on and perform a few service adjustments. Hit the power button. Boom! Flyback blew up, sent smoke out all over my shop, stunk up my shop. So I called Tritronics and gave them an earful, and she still stood me down that what they sent me was an RCA original. Well, after going round and round with them, I got my money back, and I found a supplier that had the actual RCA part, put it in there, TV worked like a charm. And the person I sold it to, or gave it to, or whatever I did, I never heard another word out of them. Now, I'm not going to take the FET off of this module. It took me a little doing to construct that, and this works. So we're going to figure out a way to mount this to the chassis, the motor board of this, and wire it in permanently and neatly. And this still is a little shrill sounding, even with the capacitor across the tone control or the output transformer. But hopefully once I mount everything back in the cabinet, it'll sound a little better. I could put a bigger capacitor in there, but I think we'll just leave well enough alone. While we're waiting for the soldering iron to warm up, this mechanism has been cleaned and lubricated. However, I'm probably going to replace these motor mounting grommets. The originals were dry rotting and crumbling, so I replaced them with some I had on hand for now. They're not in the best of shape, so I'll order some fresh ones. And also, this lever is a little bit bent. Sometimes the platter wants to rub on the speed control lever. And on these cheaper record players, it's rare to have one with a platter that's running straight. They usually run a little crooked, and when your lever's bent just a little bit, it will rub sometimes. Okay, I managed to attach a small terminal lug to the little circuit board and mounted it on the motor board like this. Yeah, it could be neater, but it could be a lot worse. So I'm ready to put this back together and enjoy it. Now, probably eventually I'm going to replace that 89T cartridge with a P228 cartridge. This will still have enough gain to give satisfactory performance with that cartridge, and it will give us a lighter tracking cartridge with a reasonably priced user replaceable needle. Not something that's going to cost you $25 for a new cartridge and needle assembly. Okay, good. Now at the end of this video, I will put the scans up of these schematics, and in this wide open space up here, I'll draw the schematic of the whole thing. Now the only change I made to the power supply area is we used a polarized power cord and wired our switch in the hot side of the line, which is the narrow blade prong on the power plug, and that helps reduce any shock hazard, providing that your AC receptacle is wired correctly.